Hi everybody. Welcome to our last lesson of, what is it here? Unit 4, Angles and Polygons. So we've done a lot of what are the different names of the angles. We did some stuff on triangles, measuring angles, making angles when we're given a certain number. So using a protractor and a ruler, etc. So we've done a lot of that work so far in this lesson, or in this unit. And we're going to finish off with something called quadrilaterals. Oof, that's a big word. Some of you may have never heard of that word before. So I'll try to simplify it as much as I can. I guarantee you have heard of some quadrilaterals when we touch on them. But basically a quadrilateral is any four-sided shape. Okay? So anything that has four sides, straight lines, and they're connected, it's enclosed. So obviously we know that a square or a rectangle, these are the two most common quadrilaterals that you're going to come across. You'll have parallelograms, okay, you'll have other, like a trapezoid, okay, you'll have other four-sided shapes that you'll come across, and all in all, they're called quadrilaterals. Okay, so now that you know what a quadrilateral is, let's learn a little bit about the angles in a quadrilateral. Well, last lesson we learned about triangles, okay? And we know that a triangle has 180 degrees. Okay, 180 degrees. In every single triangle, the angles of the inside of a triangle, this, and this, add up to 180 every time. Well, let me show you a little trick about every single quadrilateral. You can always cut a quadrilateral into two triangles. Two triangles. Well, let's think about that. Two triangles. 2 times 180 degrees equals, I'll let you see if you can do that in your head, or real quick with a calculator or something. 2 times 180, 360 degrees. So what does that mean? It means that every single quadrilateral, whether it's a square, a rectangle, a parallelogram, if you measured all of the angles on the inside, they will always add to 360 degrees. Okay, pretty simple concept. Well, let's see if we can prove that. Okay, let's try with our paper again. So we'll grab a piece of paper. Okay, you can take this piece of paper, pretty simple, if you took a protractor, okay, and you measured each of the angles. Well, this one's pretty simple, right? They all just add up to, they all measure 90 degrees because they're all right angles. So a square and a rectangle are pretty easy. 90 plus 90 plus 90 plus 90. Okay. Well, what about turning this into two triangles? How do I do that? Well, let's see what happens when I just cut corner to corner. Probably would have been better off drawing a line first, but I'm kind of estimating, I'm guessing, trying to get to that other corner. Pretty close. Oh, look at that. Two triangles. Well, again, we learned last time triangles, the interior angles. So if I took this angle plus this angle plus this angle, I would get 180 degrees. Well, now I'm just taking this portion, and this portion, and adding them together. Well, 180 plus 180, always going to give me 360. Okay, and I would challenge you to make different shapes on a piece of paper, different looking quadrilaterals, make ugly ones, make weird looking ones, like here, 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 there. Okay, or maybe you've got this side going there, that side going there, this side here, and that side there. Okay? You'll always be able to go from one corner or vertex to the opposite and make one triangle, two triangles. Now the triangles might not be the same looking, but we learned it doesn't matter what a triangle looks like. If a triangle's like this, or if a triangle is like this, they both equal 180. So no matter what, this is 180, this is 180, this is 180, this is 180. They're all going to, the angles on the inside are going to add up to 180 degrees in both triangles. Therefore, every quadrilateral is 360. Now, you think we can relate that to other shapes? We sure could. How about a five-sided figure? So 1, 2, 3, 4, 5. Well, it always goes back to this triangle. Can we make triangles? So you start at one vertex. Oh, look. I just made 1, 2, 3 triangles. What do you think the angles in a five-sided figure, a pentagon, what are those going to add up to? Well, if there's 3 triangles, 180, 180, 180, add them up. 0, 4, 2, 540. 540. If I took a protractor and I measured this, and this, and this, and this, and this, I'm going to get 540 degrees. Even if it's not a nice, good looking, where all the sides are the same length. Equilateral. Okay? What about a hexagon? A hexagon is a 6-sided. Well, how many degrees are going to be in this guy on the inside of all of these angles? We could use a protractor, or we could do our triangle trick. Start at one of these. It doesn't matter which one you start at, but you have to come from only one. So let's start down here. Connect, connect, connect. And obviously this and this is already connected. So I've now got 1, 2, 3, 4 triangles. All I got to do is add another 180 to this. So our hexagon, what's 540? Plus another 180. 720. Okay, so we can see the relationship here between a triangle and its interior angles and other shapes. These are all polygons. Okay, so our unit's called angles and polygons. This is a polygon, a polygon, a polygon. A polygon is a shape, an enclosed shape. So we're focusing on angles in a quadrilateral. Now you'll know that with our triangle, some of the problems that they gave us were this is 60 and this is 50. What's this side? Well, we know it adds up to 180. So 60 and 50 is 110. Let's just subtract. That must be 70. Very good. Well, what are we going to do with quadrilaterals? It's going to be very similar. Okay? So let's do a quadrilateral. Doesn't have to be a nice looking shape. Okay, so there's my quadrilateral. It's got 4 sides. Let's say that this is 35. This looks like bigger than 90, so let's label it as 110. Let's say that this looks about the same, but maybe, yeah, sure, let's go 35. Okay. What's the last angle? I'm going to let you pause the video here and see if you can do the math to figure it out. And then when you're ready, you hit play again. Okay. Same process as what we did with the triangles. We add up what we have. So we have 110, 35, 35, add them up. $180. Well, I didn't choose very good numbers there, because that would mean that this is a straight line. So, let me fix that little bit of a mistake that I made. You probably went through your math and you did it. You said that x equals 180 degrees. And if you said that, you'd be kind of right. That would add up to 360 the way we need it to. However, when we look at this, we can see that this angle is not quite 360. So that was my fault for choosing the wrong numbers here. Let me measure with my protractor to see where I went wrong. So this one is about, it's about 40. This one is about 35. And this one is about 120. So I kind of underestimated these two, which made that answer not really make total sense. So let's do that again. So I'll give you a second to pause and see if you can come up with a new answer for x. Okay. Add up what we're given. 120, 40, and 35. So now we've got 195 used up. We know that a quadrilateral is 360. Subtract that. 195 that we already know it, we have it. And what do we get? 165. So we got to do some borrowing, right? 6 goes to a 5, that's a 10. 3 goes to a 2, that's a 5. Okay, so 165 degrees equals x. So that's what x is, 165. Makes sense, right? That all adds up. So that's the kind of word problem, or the kind of quadrilateral problem that you're going to come across in your worksheets. Let's do a couple more. What if you're given one that looks like this? Okay, so let's say that you're given this as a word problem, or just as a problem, as a question, and you're asked to find x. Well, I'm only given 2 out of the 4 interior angles. So I can't just simply use my method of what do I have, take it away from 360, that's what x is. I need 3 angles. Obviously, they gave us this one for a reason, because we know that a straight line is 180 degrees always. So this we should be able to find. 180 minus 110 is 70. Now we have 3, and we can figure out x. So we're given 100, 95, 70. Let's add them all up. 265 degrees out of 360 are used up. So 360 minus 265 should leave us with 95. So there we go. We found x. We found our missing angle. Now, of course, I'm just making these angles up, so I know they might not be 100% accurate. But my math, where they're adding up to that 360, should always add up. When you get to your questions in your book, those numbers will have been measured with a protractor every time. My examples are obviously just made up questions. So, let's have a little peek at the shapes that we have, the questions that we have in the textbook. So, question 1, again, I'll refer to the textbook here on page 150 and 153 first, and then I'll talk about your handout sheets that I gave you on Unit 4, Lesson 7, and then we'll talk about the EP that you'll do for handed. But the first question here asks you to draw 3 quadrilaterals, measure and record each angle. Okay, so go ahead and give that a try. Use your protractor. Any shape will do. You can use graph paper, it'll probably make it easier. Question 2 is just like these questions here. You're given 2 or hopefully 3 sides, or maybe 2 and you have to find another one to get that missing side. Sometimes they'll say, here are 3 angles in a quadrilateral. So, let's pretend that they give you this as an example. Angle A equals, angle B equals, angle C equals, angle D equals. Let's say that they say, this is 100, this is 22, this is 95, and this is 98. Is this a quadrilateral? Could these angles be in a quadrilateral? So could this work? How are you going to find that out? Are you going to have to make a shape with these angles in it and see if you can make that? No, that would be really difficult. You could try, but it'd be difficult. Before you try, what you should do is ask yourself, well, do these add up to 360? If they don't add up to 360, no, there's no way it works. So let's just simply do that. Let's add them up. Okay, 8 and 2 is 10, plus 5 is 15. Well, I could probably stop right there. There's no way it's going to add up to 360 if the number ends in a 5. Okay? 18, 21 with a 2, 315 degrees. This only adds up to 350 degrees. There's no way it can be a regular quadrilateral. No way I can make that shape with these angles in it. Okay, so there's a couple of questions like that where it gives you 4 numbers and says, is it possible? You just got to do some adding, do some math. They have a question on a pentagon in here. Okay, and we learned that a pentagon has 540 degrees based on how many triangles you can fit inside. Okay, and it does do a little bit of work with triangles within a pentagon, so I challenge you to see if you can do that question. Other than that, these questions are very much like what we did here. They give you 3, you need to find the one missing one. Based on every quadrilateral will have 360 degrees. So now over to your worksheets. Okay, same type of questions, gives you 3, find the missing one. It asks you, are these possible? If it is, draw it and label it. So you look at A, B, and C. If you can make a quadrilateral, that means they add up to 360. It challenges you to draw and label it properly. Okay, good luck with that one. Question number 2, find the missing angle. It gives you 3 and you need to find 1 more. Okay? There's a little bit of that upper level thinking question at the bottom. It's called stretch your thinking. Is it possible to make a quadrilateral with 3 obtuse angles and 1 right angle? And you'll have to know, you'll have to think back to how many degrees are in an obtuse angle and how many degrees are in a right angle, and could you come up with 4 numbers that add up to 360 and they fit that bill. Okay? We'll see how you do with that one. I'll wait to hear for that one on Monday. Okay, and the last thing is your EP. This is the hand-in assignment. Exact same type of questions. Find the missing angle. So, this wraps up our Unit 4 on angles and polygons. Okay, once again, quadrilaterals, any four-sided figure. Squares, rectangles, they could be irregular figures as well, like the ones we worked with here. So, give the assignment a try, give the EP a try, do some textbook work. Anywhere along the line that you have questions, feel free to message me or get a hold of me, and I can try to do some more work on the board or talk to you over a Google Meet. Okay, so good luck with that. Next day we'll be doing some review on Unit 4. Good luck.